Okay, this question is asking which point is a solution to the equation 3x minus y equals 2. So which of these points is a solution to that? It's very easy to check. Basically, it just wants you to check. For each of these points, we're given an x and a y value. For the first point, our x value is 1 and our y value is 1. So if we want to check if this is a solution to that equation, simply substitute an x value of 1 and a y value of 1. So it would look like this. 3 times 1 minus my y value is 1. I always substitute with parentheses, and I encourage you to do the same. Equals 2. We're just going to check that point. 3 times 1 is 3 minus 1 equals 2. So you notice that works great. So that means this point is a solution to that equation. Let's check the next one. Is this point a solution to that equation? So if our x value is 2 and our y value is 4, will it still be a solution? And if you want to do this mentally, you can. You can just do 3 times 2 is 6. 6 minus 4 equals 2. I just want you to understand what it means to be a solution. When you're given an x and y value, and if you want to know if it's a solution to the equation, it's much like what you did before. You simply substitute the values and see if it makes the equation true. So in this case, my x value is 2. So 3 times 2, right there, minus my y value is 4, equals 2. We're checking this. 6 minus 4 equals 2. So yes, that is a solution to this. Our final point, we're given an x value of 3 and our y value of 7, and we want to check if this is a solution. So my x value is 3, my y value is 7. So it would be 3 times 3 minus 7 equals 2. 9 minus 7 equals 2, which is also true. The point of this is to show you that when you have a linear equation like this with x and y values, there are an infinite number of possibilities that will make it true. Here's 1, 1, 2, 4. In fact, when you develop the pattern, which we will do later on, if you start developing the pattern, you can come up with a lot more solutions. I'll give you an example here. If you notice here, we have 1, 1, 2, 4, 3, 7. The x value is changing by 1 every single time. So I'm going to show you some more solutions to this. 1, 2, 3, I could say 4, 5, 6. Look at my y value. My y value changes from 1 to 4 to 7. It's increasing by 3. So I could put 10, 13, and 16. So there's 3 more solutions right there. If you want to verify it, plug in an x value of 6 and a y value of 16 up there. Watch what happens. 3 times 6, that's where my x value goes, minus my y value of 16 equals 2. 18 minus 16 equals 2. Perfect. So all of these points satisfy that equation. What you're going to notice is when you take all the points, all these ones that are solutions, and plot them on the grid. Let me fit this in so you can see it clearly. It's going to look a little bit squeezed there, but hopefully you can see that. If you take that first point I gave you, 1, 1, x is 1, y is 1. There it is. Our second point, x is 2, y is 4. There it is. Third point, x is 3, y is 7. There it is. What you're going to realize is that all solutions to a linear equation must follow a path. They must follow a straight line. So any point that's on this straight line will satisfy that equation. And only the points that are on this line will satisfy that equation. So for example, if I wanted to, I could look at this equation and say, it looks like this point right here is on the grid, right there. Well, that point has coordinates of x value of 0, y value of -2. So if I were to substitute that into the equation, it would work as well. 3 times 0 is 0. Minus -2 really means 2.